Hello and welcome to Flipped Maths with Mrs. D. Hoog. Today our topic is equivalent fractions, and we are learning to figure out fractions that show the same amount or that are equivalent. So remember to stop and rewind and re-watch the video if you need to at all during this video. And remember to record our learning goal on your homework sheet as well. Let's start off with some important information. Just to revise and refresh our memory, a fraction or fractions represent an equal part of a whole. So if we imagine that this circle here was a piece of cake or a pie or something like that, a whole cake or a whole pie, if one part here of 4 parts, so 1, 2, 3, 4, if one of these parts was taken and eaten, we could say that 1/4 or 1/4 was eaten or taken away. So equivalent fractions, just got an example here to explain what this actually means. And equivalent fractions are fractions that are of the same amount, I guess you could call it. So for example, half is the same as, or it's equivalent to, 5/10 or 5/10. Now I've just got two different types of models here. I've got the circle one and then the bar ones. We'll just cover that one up. This one here represents 1 out of 2 parts. There's 2 parts here. So 1/2. And I've got the equal sign. And then over here I've tried my very best to draw 10 parts of maybe a pizza or a pie or something like that, where it's shared equally, because remember that fractions are equal parts of a whole. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts, which is that one there. The number at the bottom of a fraction is always the total number of parts, and then the number at the top here, the 5, is how many parts we are talking about. So here we are talking about 1, 2, 3, 4, 5 parts of the 10. 5 out of 10 or 5/10, 5/10, lots of different ways of explaining that one. And then as you can see visually, half of this circle is shaded in, and half on this side here, the red part, half of it is shaded on this side as well. And I've kept those green lines in between to show you the parts, so that there are 5 coloured in there. This one here is the same thing. We've got half represented here, so 1 out of 2 parts are shaded. And then down here, the little equal sign is the same as 1, 2, 3, 4, 5 parts of 6, 7, 8, 9, 10. So 5/10 or 5/10. And it's saying that it's the same amount here, it's just written in a different way. So we're going to go through a few examples in just a moment, but before we do, I'm just going to show you this fraction wall, I guess you could call it. And basically what we have here, just see if I can, there we go. We've got the first one, which is 1, which is a whole, and then this one here, 1/2 and 1/2. They represent halves, and then we've got these ones here, the 1/3, and there's 3 parts there, because 3 is, saying there's 3 parts of the whole, 1 part, 2 parts, 3 parts, so it's thirds. These ones are called fourths. The next ones are fifths. Have a notice that it's a 5 and there are fifths. Each one of these, so 1/5 is 1/5. If we had 2 of these ones here, it would be 2/5. And next one is sixths, sevenths, and then eighths at the bottom here. Notice they've got that, most of them have got the ths at the end. It's quite tricky, but make sure you say it when you're referring to fractions, otherwise it will just sound like sevens, which is incorrect if we're talking about sevenths. Alright, so now we've got that one sorted. We can actually use this sort of fraction model to help us, solve fraction problems or equivalent fraction problems. So I've just got a little sheet here, which has got a few examples on the left-hand side. And I've got these little asterisks to show that there is a missing number. Find the missing number. this is the same as the other question, I guess, with the 1/2 equals 5/10. We're looking at, well, what is the equivalent? What number could we pop above the 4 here? What part of 4 of a whole, what part would equal the same as 1/2? You could just grab this one and you could go, well, 1/2 is how many quarters? 1 2 quarters. So then you could just write 2. Another way of working it out, which is something that I learned when I was in school, was that if you have got this missing number here, and you've got the 2 at the bottom or the 2 at the top, you can actually use multiplication or division. So in this case, I'm going to use multiplication because it's going up. So I know that 2 times 2 is 4. Therefore, I need to make sure I multiply the top number by the same to make it even or equivalent to be the same as. So 1 times 2 is 2, and that's the answer we got by looking at the fraction rule anyway. So interesting. The next one here, we have 4/6 equals or is equivalent to however many thirds. Now, you could just use the fraction rule, so you could go over and say, well, I know there's 4/6, and I'm just going to try and bring it up closer. 4/6, there we go, 1, 2, 3, 4, and I want to find out how many thirds is that worth. So I can go up to the thirds, and that line here, 1, 2, 3, 4, 6, actually covers 2, because that line there matches up. So 2/3 is the same as 4/6. And to double check our answer, we can just go this way, because with arrow changes, because it's going from a small to a big, and I like multiplying in this, it's a bit easier. 3 times 2 is 6, so therefore 2 times 2 is 4. In this case, if you didn't have a fraction wall, you could have gone the other way, which in hindsight, it would have been easier to think, 6 divided by what is 3? Well, 6 divided by 2 is 3, and then we've got 4 divided by 2 is 2. It's another way of working that one out. And then we've got this missing number here. Something over 6 is the same as 4 over 12, or 4/12. Now, we actually haven't got 12ths on this little fraction wall here, so that becomes an issue if you're using the fraction wall. So I'm going to use this strategy of arrowing or drawing an arrow and multiplying or dividing. In this case, I am going to be going this way, and I know that 6 times 2 is 12, because 6 plus 6 is 12. There are 2 lots of 6's, so I'm going to multiply this one here, covering up that one. So, hoping that can still be seen, yep. Alright, so then something times 2 is 4. You could just say 2 times 2 is 4. You could have done it the other way around, like I did in this one here, and you could have gone this way, which is possibly easier. Depends on the way you like working it out. So divide by 2, so 12 divided by 2 is 6, or half of 12 is 6, and then you would say, 4 divided by 2, or half of 4 is 2, and there's your answer. It's another way of checking it, I guess, as well. So now, year 4s, it's your turn to have a go with these practice questions. I'll just cover up, I guess I could just leave the examples there, so when you're pausing the video you can refer to them if you need to. We've got these ones here. We've got question 1. 1/3 or 1 over 3 is the same as how many sixths? Or 1 over 3 is the same as what over 6? Question 2 is 5/10 or 5 over 10 is the same as equals how many over 2, or how many halves? Then we've got 3/8 is the same as how many 16ths? And then something over 4 is the same as 2 over 8, and half is the same, or 1 over 2, or half is the same as how many over 100, or what number over 100, I should say. So year 4s, make sure you pause the video now, and if you need to look at that fraction fraction ladder, or the the fraction wall, just pause the video, rewind it if you need to. But make sure on your homework sheet that you write out all of these parts here, and including your answer there. When you're writing your answer, just rub it out, or don't write the little asterisks there. That's just to remind you that this is the missing number. But make sure you write it all out so that you can look back later and know what it was all about. So just remember, Year 4s, that today we were learning about equivalent fractions, making sure that they are balanced, I guess, on each side of the equal sign. And thank you so much for listening to and watching this video.